Hello, everyone. Welcome to this session. It's a pleasure to be here at J4K. It's the second time that I'm presenting. And today we have a very nice subject to discuss. We will see how to do advanced deployment techniques with Kubernetes. And we will use not only Kubernetes, but we will use a service mesh through Istio. And it's nice to see those kind of things that goes beyond development, because sometimes you need to release a software and you don't want to have an issue during the deployment time. So I will go through some very particular ways of deploying software, and hopefully everything will work with zero downtime live, because I will show that in a demo. So I will start sharing my screen because we have a lot of things to see. So let me first share my screen, and you can have access to the slides at this moment. If you go to this link here, bit.ly/ddeploymaster, you will have access to these slides. At this moment, I'm working at Oracle as a product manager for a product called OCNE, Oracle Cloud Native Environment. And I was a Red Hat employee for 10 years. So I've been working and practicing everything related to cloud native development. But let's start talking about the deployments. If you record, I don't know if you're familiar to this phrase, to this sentence, in the Forbes magazine in 2011, they said, now every company is a software company. And if you start to think, Uber, for example, they don't have any cars. They don't own any cars. They have an app. It's everything software based. It's the same thing for Airbnb. Airbnb does not own any real estate. It's all based on the application, at the app. And you can think the same way for Alibaba, or that they don't have inventory, that they don't have things in their possession besides the application. And even Facebook is the world's largest content provider. You can question the kind of content that Facebook produces, but again, it's everything based on software. So we see that the world changed in all areas. It changed in the development process, where we saw waterfall becoming agile, and now we talk about DevOps. We saw there in the application architecture space, we started producing monolithic applications, then the 3 tiers, N tiers, and finally we are doing microservices. In the deployment area, we came from physical servers to virtual servers, and now we talk about containers. And finally, in the application infrastructure, we are talking about clouds. So the focus of the world in the IT industry at this moment, and the focus of this presentation, is the DevOps, microservices, containers, and clouds. But some things never change, no matter. So suppose that you receive a request to produce a new feature for your application. You need to plan, develop what was planned, test, place it on production, and finally deploy it on production. And usually this deployment cycle takes 3 months. So the user takes 3 months before you or the user who requested a new feature to get a feedback and learn with the thing that has been deployed and create a new loop. Because this loop of planning, development, QA, UAT, and deploy never stops. And the thing here about the feedback loop, it's something very important in all areas of your life. So no matter, for example, suppose that you are learning how to walk, you depend on the feedback of the gravity, right? If you are learning how to talk when you were a child, you depended on the feedback of your parents, of someone who cared of you to see you should talk that way or this way. Or when you are learning how to create software, you depend of the feedback from others to say, you should do this way or that way. You could use that design pattern to improve your solution. So the feedback loop is very important. But in 3 months of a traditional development cycle, how many features, bug fixes, changes, configuration changes can be implemented in 3 months? It's a lot of things. And suppose that one thing goes wrong. How do you know what particular change caused that bug? So that's why the batch size is also important. If you can reduce the batch size instead of doing this feedback loop in 3 months, and if you could release your software in 1 week, how many learning opportunities you would have, and how much your software would improve in questions of months when you compare to a development cycle that takes 3 months, right? So if you can reduce the amount of your batch size, your software will improve faster than another one that takes longer, okay? Of course, when we talk about deploying a new release every week, we face what was very popular in the past, the maintenance window. You can remember when you were about to access our website on a Saturday night and you saw, it was very common to see this software or this page is going through maintenance and we should return on Monday. That was very popular. Finally, nowadays, we don't see that very often. But that was possible because of the zero downtime deployments. How you can deploy your software at any time at Wednesday noon and keep your software working. It was very popular also to have a problem where dev and ops were working away from each other. The dev just threw away a jar file on the heads of the operation people, and they were responsible to place that software in production. Finally, with the DevOps movement, there is no more wall of confusion. They are both reliable for making the software work on production, right? So we will see some techniques here, and as I said, I will demo that online, and hopefully during the deployment, my software will be online all the time. Okay, and the first pattern for zero downtime deployment is a technique called blue-green deployment. So what is a blue-green deployment? In the past, we had all the clients, all the browsers accessing directly my application, which was called a blue environment. To have a blue-green deployment working, we need to introduce a proxy in the middle. And what this proxy will do is that it will balance between two environments. I can create a green environment in parallel, also running in production, and then I will send and I will configure my proxy to send all the requests to the blue environment. Then if I want to release the green environment, I just switch the key in the proxy to the green environment. And if something goes wrong, I can just return to the blue environment, right? Let's see that working with Kubernetes. I have here in my demo environment, I have, if I do kubectl get pods here, you will see that I have some pods running. I have a hello microservice, MySQL database running here that I will cover later. And I have two versions of Olá. Olá means hello in Portuguese. I have Olá version 1 and Olá version 2. If I access those microservices, you will see a round robin between them. Version 1, version 2, version 1, version 2, and so on. Sometimes it will land in version 2, sometimes it will land in version 1. Why it acts that way? Because if I get the service who describes this microservice, the selections label is for everything that has the app Hola will receive the request. So my endpoints are the two endpoints that I have here, these two pods, the version 1 and the version 2. If I want to select everything, if I want to make everything to go to version 1, what I need to do is to add a new label to this selection label here, specifying the version. So I have a script here that will update my service. Let me perform a blue-green deployment for version 1. Note here that once that I call this script, you will see here a selector saying app Hola and the version v1. And now, let's wait. My CPU is freaking out, so that's why it's taking a little bit longer, because I'm streaming and doing the demos here, but we can see that only v1 is replying now. If I want to go to v2, it's easy. Let's patch the service and change here from v1 to v2, okay? So let me do it here. Now we have v2, and it changed here from v1 to v2 with zero downtime, because both replicas are live. If I want to return to blue-green version 1 and version 2, I just remove the version from the selector. Okay, let me apply here. And now this is just a disconnection failure because I interrupted the connection in the middle. Okay, but as I said, the idea here is to perform a zero downtime deployment. And okay, these issues here might be because of Istio stopping just to work. Let me see. kubectl get pods in the name Istio system. Yeah, it crashed. So let me see what I will do here. While I will restart my pods of Istio, all of them. And I will stop my video to save a little bit of resources, okay? But you will continue to see my screen. Okay, while we have kubectl get pods in the namespace Istio, let's wait them for become ready. Let me show to you what is another feature, another deployment pattern that we can do. Okay, rolling upgrade. Rolling upgrades, it's easy. It's the default pattern for Kubernetes. And for example, suppose that you have 3 replicas and the proxy is balancing among these 3 replicas. What the rolling update does is to start a new version, and when it's working, it will proceed to the next one. And when the second one is working, it will proceed to the third one. Okay, so let's see that working. Let's see if we can access let me access through the node port, because we don't need Istio at this moment. Okay, we have v1 and v2 running. Let me get the pods in the microservices namespace. And what I will do now is to deploy a new version. So let me perform a rolling update for version 3. Note here that when I deliver the version 3, it will create a new pod with the version 3. You can see here container creating. This is the name of the pod, so don't worry about this. But it will create v3, and once that is running, connection refused. I don't know why yet. But we can see here v3 working, and then it will start to terminate the version 1, and then later the version 2. Probably all these things that we are showing about connection refused is because my VM is running crazy about the CPU. My usage of CPU is very high at this moment because I'm streaming the content. So you can see that we have now v3 and v2. Now the rolling deployment will roll the next version, and now we have everything running v3. Oh, we have v2 yet. Oh, I updated just v1 to v2. Okay, now suppose that I want to return to v1. Yeah, I just updated the v1 deployment. So we have v1. V1 was replaced by v3, and so we have v3 and v2. Now let me return v3 to v1. Oops. Now you can see that it will create v1 and it start to kill, to remove v3, as we can see here, terminating. Okay. Now let's continue, because another thing that I really like is the idea of canary deployment. So what is a canary deployment? Canary deployment was based on the coal miners, the British coal miners, where they carried a small canary to the mines. And that means if the canary was happy and singing, it means that there was no gas leakage at all. Everything was working. They were able to be inside the mine. But if the canary stopped singing, there was a problem. There was a gas leakage. Of course, in that time, there was the canary resuscitator. So the canary didn't die, okay? The idea is not to do any harm to the canary. But in the software industry, the canary version is the idea of delivering, it's to release the software and send just a small traffic to that version. So you can try, if there is something wrong, only 10% of the users would see that error coming from that canary version. So you reduce the risk. But if everything is okay, you can start to increase the traffic on that canary version. Of course, if something goes wrong, you can remove the canary version from the load balancer. In Kubernetes, we can do canary releases, but it's always 50%. Like we saw, there was version 1 and version 2, and each one of them was receiving the same amount of requests. But now comes in play Istio. With Istio, we can manage the traffic and say to Istio how much amount of traffic we want in each version. So what we will do now is to show to you, by the way, just let me do a brief introduction of Istio, because we will use Istio features a lot. Istio is a service mesh implementation. So before Istio, each microservice needs to have a discovery, load balancer, resilience metrics, and tracing on each application. With Istio, all those features, all those capabilities are inside the Sidecar container. So the idea of the Sidecar container is to intercept all the network traffic and then perform what is needed in terms of traffic management and other things before sending the request to your application. This Sidecar container runs a proxy called Envoy, which is a very performatic proxy written in C. Okay, so let's see. Let me check how is my environment. Okay, let me see how is Istio going, right? Yeah, everything seems to be working. Let's access my application through Istio. Yeah, it's working. And now I'll go through a console of Istio called Kiali. Kiali allows me to manage the workload. So let me just reopen here the dashboard. Nope, I want Kiali. Grafana is working, but Kiali is not yet ready. Let me see if Kiali is running. Okay, you can see that my CPU is really high because to show my page is taking a while. But let's open here the service Hola. And by the way, let me see. And I have two workloads. I don't know why it's showing missing sidecar because the sidecar is there. Let me see. Oh no, it's my sidecar is not there. Let's delete pods, the namespace microservice. Of course, I need the sidecar, right? So I will just kill my microservices, all of them. Grace period 0 -- force. There's something strange. Let me just proceed with the deployment because yeah, I'm running the deployment again from Jenkins, just to make sure that it will configure my microservice to have the deployment. Okay, but the idea is that with the Istio, with Kiali, we could control how many replicas, how many, what's the percentage of traffic that will go to a version 1 or to a version 2. Okay, but let's move forward, and if we have available time, we will return to this demo. Okay, let's continue. Another thing that's possible to do just with Istio is the idea of A/B testing. Because what is A/B testing? Like for example, everyone has an idea on what changes you can do in your software to improve the metrics, any metrics, sales metrics, performance metrics. Okay, so what is your hypothesis? So you can say that given a software, just like we see here, a typical sales page, and suppose that someone says to you, what will happen if I change this button here, add to cart, if I move it to the top of the page, it will increase my sales or not? Or if I change my recommendations algorithm, will it change or not? Or if I change the picture of the product, it will improve my sales or not? So we have different ways, different hypotheses that could improve the metrics. The idea of A/B testing is that you will place both variants on production, and you will send that version to the users, and you will check what will improve the sales, or what would improve the performance. The idea of A/B tests is that, and you can do that with Istio by selecting what users will see what version. Okay, so if Istio returns, I will show you a demo of that. Finally, we can have the idea also of dark launches. So what is a dark launch? Dark launch became very popular with Facebook. Facebook released Facebook Messenger, and on production 1 year before we even see it. Because what Facebook did is get all the information, all the messages that you were posting on the other users on your friends' timeline, and sending it to the Facebook Messenger pipeline. So you can do that with Istio. You can, for example, try the service 2, the version 2 of the service, but only through mirroring the requests from version 1 to version 2. For the users will always see version 1, but since version 2 is receiving the same requests, you can check the logs, you can check the metrics, you can check everything and see how V2 would perform if the user would see if the user was receiving V2 requests. Okay, let me see how is V2, how is yeah, I don't have Istio working at this moment. So let's go through only focusing on theory. Most people also ask, what about the application state during deployments? I don't want to have a shopping cart full of things and then during the deployment lose those things inside my shopping cart. Well, in this case, we have the 12-factor app. So the 12-factor app is composed of 12 factors, or 12 practices. And the practice number 6 says, execute the app as one or more stateless processes. And there's even another description that says, sticky sessions are a violation of 12-factor and should never be used or relied upon. Session state data is a good candidate for a data store that offers a time expiration such as Memcache or Redis. That's why I used here MySQL, at least since this is not based on Istio. We can do here, let me see, scripts, deploy, and run session get. So it's getting everything that's in my session. And if I do here, I configured my microservice to store every session data in MySQL. So if I add something in my session, for example, if I add J4K, you will see that every microservice will have the same replica. Of course, it's taken, there are some here that's not configured, but J4K has been replicated. And finally, we have CI/CD deployment pipelines, where the idea of the pipeline is to release the software in the hands of users safely, quickly, and sustainable way. If you have a pipeline running, when you need to release a software on production is where during the stage, from the stage environment to production environment, you will choose one deployment patterns that we saw previously, okay? Well, since our time is over, I will stop here for and open for questions and answers. And while you are thinking about the questions that you might have, I will see why my demo environment stopped working. I know that is because of the CPU usage, but at least some things should be able to. I like to demo to you, okay?
While you do that, Rafael, there are two questions. The first one is, could you show the presentation link again?
Sure. So the presentation links is here. bit.ly/ddeploymaster.
Thank you. And the next question is, you mentioned you can do blue-green, rolling upgrade, and canary with Istio. Can Istio also do rollbacks?
Yep, Istio can do rollbacks as well, because Kubernetes, there was the rollback command in Kubernetes, right? kubectl rollback, but it has been deprecated. People are using a new deployment. For example, if you were in V2 and if you want to return to V1, you just perform a new deployment of V1 if it's not running in parallel, just like it's running here. We have V1 and V2, right? kubectl get pods in the namespace microservices. V1 and V2 are running here in parallel. Let's suppose that we have V3. That will be a new deployment, just like I will do here. Scripts deployment, rolling update V3. In this case, it will change my deployment to create V3 and terminate the previous V1. If I want to return to V1, it's just a matter of a new deployment. So in this case, if I want to return to V1, it will perform a rolling update, returning V1 to the previous state. It does not have the idea of kubectl rollbacks anymore. It seems that it was deprecated a long time ago. And personally, I'm using just a moving forward, which means that if I want to return to a previous version, it's a new deployment of the versions and containers that I had in the past. Because one good thing, one good practice of deploying a software is not deploying the latest version, the latest tag of a container. It's good to tag a container with V1, V2, and your Kubernetes files will match the version 1 that's deployment with the container tag V1 as well. Okay. Let me see. Let me see if I followed that practice. If I got here microservice demo, deployment. Oh, in this case, my tag is Java. I should use hello V1 if I'm deploying, in this case, the version 1, right? Do as I say, but don't do as I do.
Right. A question, a follow-up of that. If a rollback is a rollout of the older version, how would you handle like compensating logic that you may need to undo some kind of database transaction?
Okay. In those cases, for example, for Java applications, I use the flyway pattern. I don't handle this to Kubernetes in any sense. I just have my application to perform flyway migrations in a case of Java applications, right? For other language, they have their own way to do database migrations. And once that version starts, it will perform all the adjustments that it's needed in the database schema.
Got it. Thank you, Rafael. And I think with that, we're going to have to wrap it up. We've reached your allotted time for your session. So we want to thank you very much.
Thank you also. It was a pleasure to be in here. And you can find me at Twitter at Rafa Beni.
Very good. Thank you so much.
Thank you. Bye-bye, everyone.